The Carboniferous period was the fifth period of the Paleozoic era, beginning about 355 million years ago and ending around 290 million years ago, lasting roughly 65 million years. During this unusual chapter of Earth's history, dense vascular plant forests, a warm and humid climate, and exceptionally high oxygen levels created near-perfect conditions for life to flourish. However, these life forms looked nothing like the ones we recognize today. Giant insects ruled this primordial world, turning the Carboniferous into a land where enormous arthropods roamed freely, a place that would feel less like a nature documentary and more like a waking nightmare. In the Carboniferous, lush tropical forests absorbed vast amounts of carbon dioxide through photosynthesis while releasing equally vast quantities of oxygen. As a result, average atmospheric oxygen levels reached about 35%, with peak concentrations exceeding 40%. This oxygen-rich air provided ancient life with an abundant energy supply. Although early vertebrates had not yet fully adapted to life on land, this period was ideal for their evolution and rapid growth into large body sizes. This era featured centipedes as long as cars, dragonflies comparable in size to modern hawks, and spiders and scorpions as large as household dogs dominating the ancient continents. If you were dropped into a Carboniferous jungle, the first thing you might notice, thanks to the extremely high oxygen levels, would be dizziness, lightheadedness, and blurred vision. In such an oxygen-heavy environment, even damp wood could ignite from the tiniest spark. Looking down, you would find your feet sinking into muddy swamps, as wet, marsh-covered landscapes were a defining feature of the Carboniferous. The most astonishing sights, however, would be above your head. If you looked up, you would see bird-like creatures circling the sky, their wing beats producing a deep, vibrating hum in the air. These were not birds, nor modern insects, but prehistoric insects, giant net-winged species resembling butterflies. An average individual had a wingspan of about 40 centimeters, while the largest reached up to 55 centimeters, roughly 10 times larger than many flying insects today. Their most striking feature was their exquisitely patterned wings, covered in delicate, net-like designs that looked like natural works of art. In addition to two pairs of brightly patterned wings, small protrusions near the head may have helped with balance during flight. They also possessed a long, straw-like proboscis used to suck plant juices, representing an early form of herbivory. Despite their intimidating size, these giants were completely harmless plant eaters, interested only in sipping nutrients from vegetation. Ground-level predators, however, were a very different story. In the Carboniferous, silent roaming hunters posed a lethal threat to almost any creature. If you spotted a massive animal on the forest floor, it was almost certainly one of the most dangerous beings around. Among them was Pulmonoscorpius, the largest scorpion known in Earth's history, reaching lengths of up to 71 centimeters. By comparison, the largest living scorpion today, the emperor scorpion, grows to only about 20 centimeters. Pulmonoscorpius was encased in a hard chitinous exoskeleton that provided excellent protection against attacks. Its powerful pincers ended in sharp claws capable of firmly gripping prey, while its curved tail carried a venomous stinger. Once that stinger penetrated a victim, the outcome was essentially decided. Pulmonoscorpius fed on smaller arthropods, mollusks, amphibians, and reptiles. It could hunt both on land and in water, an amphibious lifestyle that made it remarkably well adapted to the ancient world. If you encountered such a giant scorpion in a Carboniferous jungle, you would notice it immediately, and it would notice you just as easily. It possessed two pairs of eyes, a primary pair for spatial awareness and prey localization, and a secondary pair for detecting light. Its body was also covered with sensitive receptors that further enhanced its hunting abilities both on land and in water. Even if you were not naturally afraid of spiders, coming face to face with a 70-centimeter-long venomous scorpion would almost certainly awaken an instinctive fear of arthropods. Now, let us leave these terrifying ground predators behind and return to the skies of the Carboniferous. Above the primeval forests, alongside harmless butterfly-like insects, flew some truly enormous aerial predators. These creatures looked very much like dragonflies, except they were more than 10 times larger than their modern counterparts, making them the undisputed rulers of the ancient skies. Meganeura, one of the largest flying insects in Earth's history, resembled a typical dragonfly in form but on an entirely different scale. Its wingspan could reach an astonishing 70 centimeters, a size that redefined what insect meant in the Carboniferous world. With a body length of about 40 centimeters, these giants were roughly comparable in size to modern birds. As early as 300 million years ago, such enormous insects had already become terrifying aerial hunters and ranked among the top predators of the Carboniferous skies. Their reign lasted until the late Carboniferous, when the first gliding reptiles appeared and finally challenged their dominance. Giant dragonflies possessed enormous compound eyes that provided an almost 360-degree field of vision, allowing them to precisely lock onto prey from above and below. Their forelegs were armed with sharp spines specifically adapted for grasping prey, perfectly embodying every trait of a highly aggressive predator. It is thought that their prey may have included the previously mentioned giant butterfly-like insects. Meganeura was not only highly adaptable but also employed two distinct hunting strategies, either waiting motionless for prey to approach before launching a sudden ambush, or actively pursuing targets in midair at remarkable speed. These insects were fast, agile aerial hunters with exceptional maneuverability, easily weaving around obstacles during pursuit. In the air, giant dragonflies had virtually no natural enemies. On land, however, the situation was very different. Even the formidable Pulmonoscorpius would pale in comparison when faced with another colossal creature, Arthropleura, the largest terrestrial invertebrate in Earth's history. Arthropleura was the largest known land invertebrate and also the biggest millipede ever to exist. Among this group, even the smallest individuals reached about 30 centimeters in length, while the largest grew to approximately 2.6 meters and weighed close to 80 kilograms. By comparison, the longest living millipede today, the African giant millipede, measures only around 33 centimeters. Arthropleura's body consisted of around 30 armored segments, each roughly 50 centimeters wide, with a pair of strong legs beneath every segment. Like many arthropods, it periodically molted its exoskeleton. When the body grew too large, the old shell was shed and a stronger new one rapidly formed. Its exoskeleton is believed to have been extremely tough, capable of resisting predator attacks and securing its dominant position in ancient forests. Interestingly, direct confrontations between this massive arthropod and other animals were rare, largely because predators were relatively scarce during the Carboniferous. Even giant scorpions would likely have hesitated before attacking a creature several times their own size. So far, no fossils of Arthropleura's head or mouthparts have been found, leaving its exact diet uncertain. Some scientists speculate that these unsettling giants mainly fed on decaying plant matter and seeds. Juveniles were likely strict herbivores, while adults may have occasionally consumed carrion or even small animals. The strange life of the Carboniferous forests did not end there. In the damp swamps lurked another predator, waiting to ambush small reptiles and amphibians. This creature looked remarkably like a giant spider but was not a true spider at all. Known as Eurypterids, these crab-like predators were once mistaken for enormous spiders due to their appearance. Further study revealed that they were actually large marine arthropods. Some reached body lengths of around 60 centimeters. Their unusual body structure allowed them to feed by sweeping through soft mud on riverbeds, capturing small invertebrates such as worms, insects, and smaller arthropods. Occasionally, they also preyed on land animals like reptiles and amphibians, though these faster targets were harder to catch and therefore not their primary food source. These animals typically relied on ambush hunting, hiding in riverbeds or burrows and waiting for unsuspecting prey to wander too close. By contrast, their ancestors, giant sea scorpions living more than 400 million years ago, were more active hunters. Some species were more agile and reached lengths of nearly 1.6 meters, roughly comparable to a human's height. Even so, they were overshadowed by another colossal arthropod, Siberian Eurypterids, whose largest individuals reached about 2 meters in length. With their broad, heavily built bodies, they were likely among the heaviest arthropods of their time. Despite their size, they hunted in much the same sweeping manner as their smaller relatives, though their diet probably included larger reptiles and amphibians. The largest arthropod of all was Carboniferous, which lived around 400 million years ago and exceeded 2.5 meters in length, making it the largest arthropod ever known. This ancient giant relied on powerful claws for both defense and hunting, each claw measuring nearly 30 centimeters long, more than enough to seize and crush prey with ease. And although its body length rivaled that of a small car, it was very much alive, very predatory, and very real. However, due to its relatively simple body structure, Carboniferous likely did not exceed 100 kilograms in weight. Not all life in the Carboniferous was shaped by the trend toward gigantism. In the damp primeval forests, while giant dragonflies patrolled the skies and massive scorpions lurked in the water, some tiny creatures still hid quietly among the undergrowth, almost impossible to notice. These organisms, known as trigonotarbids, are considered the earliest prototypes of spiders. The smallest trigonotarbids measured only a few millimeters, and even the largest were no more than about 5 centimeters long. As the earliest known terrestrial arachnids, they appeared more than 400 million years ago and were already fully adapted to life on land, capable of breathing air directly without relying on aquatic environments. In appearance, trigonotarbids shared many similarities with modern spiders. Their bodies were divided into a cephalothorax and an abdomen, and their legs were covered in segmented chitinous exoskeletons with structures resembling those of living spiders. However, these prehistoric spiders lacked the ability to spin webs. Their cephalothorax was protected by a hard shell, earning them the nickname armored spiders. As some of the smallest predators of their time, they primarily fed on soft-bodied invertebrates such as worms. Unlike modern spiders, trigonotarbids likely had not evolved venom. Instead, they captured prey with their legs, restrained it, and then fed. Some evidence also suggests they may have consumed plant material, similar to certain modern mites. For an easier mental image, their form can be compared to that of some mite species with a spider-like appearance. The Carboniferous can be seen as a grand evolutionary testing ground, where unique, gigantic, and often dangerous organisms ruled both sky and land. Yet perhaps the most astonishing evolutionary experiments took place in the water, where many heavily armored ancient creatures emerged. One such tiny organism, nicknamed the Excalibur worm, lived in shallow seas around 400 million years ago. Feeding on organic debris, it measured only a few millimeters in length and could be clearly observed only under a microscope. Its impressive nickname, inspired by the legendary sword of King Arthur, was well deserved. In appearance, it resembled a miniature knight clad in heavy armor, its body covered with overlapping plates made of calcite crystals that provided exceptional protection. Beneath these crystal plates was a lighter exoskeleton, much like chain mail worn under a knight's armor. In addition, this organism possessed a remarkable defensive ability. It could curl itself into a ball, shielding the softer, unarmored parts of its body. When rolled up, the sharp edges of its crystal armor protruded outward, making it highly intimidating to predators. Whether a predator tried to bite through the shell or swallow it whole, the outcome was likely unpleasant. Although this sophisticated adaptation offered near-perfect defense, it came at a cost. The heavy armor severely limited flexibility, making feeding and movement extremely difficult. This fortress-like defense reduced its competitiveness and hindered its ability to adapt to changing environments. As a result, these organisms did not leave significant descendants, and their extinction coincided with the late Devonian mass extinction event. As amphibians continued to evolve, reptiles began to develop forms resembling modern lizards, complete with vertebrae and the ability to live and move on land. Some amphibians grew extremely large and even evolved into predators, resembling modern crocodiles with sharp teeth and body lengths approaching 6 meters. Certain species also developed thicker, scale-like skin, an adaptation that reduced water loss during long periods away from water. More importantly, amphibians evolved the amniotic egg for the first time, eggs capable of developing on land while breathing air. This innovation fundamentally altered the course of evolution, freeing these species from dependence on water and allowing them to occupy much broader terrestrial environments. With the flourishing of amphibians and early reptiles, ecosystems gradually transitioned from the Carboniferous to the Permian period. The Permian began around 300 million years ago, only about 50 million years before the appearance of dinosaurs. During this time, all continental plates merged into a single supercontinent, Pangaea. In the Permian, the first large herbivorous and carnivorous animals appeared. Some species looked vaguely dinosaur-like, but in reality they were more closely related to mammals and reptiles. One particularly strange creature was Diplocalus, about 1 meter long, resembling a salamander but with a distinctive boomerang-shaped head. Another iconic newcomer was Dimetrodon, a reptile around 5 meters long, featuring a massive sail-like structure on its back that likely helped regulate body temperature. By the late Permian, the ancestors of mammals began to emerge, with the largest among them known as therapsids. These giant creatures resembled enormous beasts, with teeth specialized for different functions to suit a wide range of dietary needs. Some were herbivores, calmly grazing on vegetation, while others were fierce carnivores built for active predation. Their body sizes varied dramatically across evolutionary history, ranging from individuals weighing less than 1 kilogram to giants exceeding 1 ton, making them key members of terrestrial ecosystems at the time. Among them was a group known as cynodonts, named for their dog-like teeth, and fossil evidence suggests that some of these animals may have exhibited pack behavior and even hunted cooperatively. In the oceans, bony fish with true ossified skeletons began to evolve, while sharks and rays flourished, and sponges and corals diversified further. Meanwhile, on land, insects continued to evolve piercing-sucking mouthparts capable of penetrating plant or animal tissues and feeding by suction, a biological straw with far-reaching consequences. However, around 252 million years ago, the Permian period came to an abrupt and catastrophic end, marked by one of the most severe mass extinction events in Earth's history. In 2001, scientists made a startling discovery suggesting that a massive comet or asteroid may have struck Earth roughly 200 million years ago, triggering a catastrophe comparable to the one that wiped out the dinosaurs 65 million years ago. Geological layers revealed abnormally high concentrations of helium and subatomic particles that could only have originated from space. Estimates suggest the impactor measured between 6 and 12 kilometers in diameter, releasing energy 1 million times greater than the most powerful earthquake ever recorded. Additional evidence indicates that enormous volcanic eruptions occurred simultaneously in what are now Siberia and parts of China. Ash and dust from these eruptions blocked sunlight, and over the next million years more than 3 million cubic kilometers of magma flooded the surface, forming lava layers up to 10 meters thick. The combination of asteroid impact and massive volcanism delivered a lethal double blow, plunging Earth into chaos and disaster. This cascade of events led to the Permian mass extinction, during which about 90% of marine species and 70% of terrestrial species vanished. This extinction not only ended the Permian period but also cleared the stage for a new chapter in the history of life. The Permian-Triassic extinction event 252 million years ago marked the beginning of the Mesozoic era, which includes the Triassic, Jurassic, and Cretaceous periods and lasted approximately 186 million years. During the Triassic, the supercontinent Pangaea was dominated by vast deserts, with a hot and arid climate surrounded by the global Panthalassa Ocean. Dinosaur evolution began in the middle to late Triassic. When people think of dinosaurs, they often imagine gigantic, roaring monsters like Tyrannosaurus rex, but recent research shows that the ancestors of dinosaurs and their pterosaur relatives were actually very small. Strong evidence for this comes from a tiny insect-eating reptile discovered in Madagascar, dating to the Middle and Late Triassic. This earliest known Lagerpetid lived about 237 million years ago, stood only 10 centimeters tall, and represents one of the first miniature species at the base of the dinosaur family tree. Studies suggest that this reduction in body size was a survival strategy for early species, where patterns on its teeth indicate an insect-based diet, allowing it to avoid competition with larger predators for meat. Research also suggests that the feathers or feather-like coverings seen in later dinosaurs and pterosaurs may have originated in these tiny ancestors, primarily as insulation to cope with the extreme climate of the Middle and Late Triassic, a critical period for early dinosaur evolution. The Triassic witnessed the rise of reptiles, mainly including archosaurs and mammal-like reptiles known as synapsids. For reasons still not fully understood, archosaurs gained the evolutionary upper hand, gradually replacing mammal-like reptiles and giving rise to the earliest true dinosaurs in the Middle to Late Triassic, such as Styracosaurus and Herosaurus. Dinosaurs are broadly divided into two major groups, the Saurischians and the Ornithischians. Saurischians include theropods and sauropodomorphs, with theropods being primarily carnivorous and sauropodomorphs large-bodied herbivores. Ornithischians were mostly herbivorous dinosaurs, including ornithopods, stegosaurs, ankylosaurs, ceratopsians, and pachycephalosaurs. Styracosaurus was an early member of this lineage, measuring about 91 centimeters in length and weighing roughly 11 kilograms. It had long, slender legs for fast running and sharp claws on its forelimbs for grasping prey. Herosaurus was more evolutionarily advanced, with a flexible joint in its lower jaw, a relatively large skull, and jaws packed with sharp carnivorous teeth. It averaged between 3 and 6 meters in length, and each forelimb bore 5 claws that, while not especially sharp, were still capable of gripping prey. Another early dinosaur, Eoraptor, measured about 2 meters in length and possessed 13 to 14 sharp teeth in both the upper and lower jaws. Finally, Coelophysis-like forms were characterized by relatively short forelimbs, rounding out the diverse and experimental early stages of dinosaur evolution, a time when the giants of later eras were still, quite literally, just getting started. Its long, slender hind limbs allowed it to run at high speed. This dinosaur weighed about 30 kilograms, and although it was not large, it could easily handle prey bigger than itself. Styracosaurus, Herosaurus, and Eoraptor were classic representatives of the rapid evolution of carnivorous dinosaurs around 225 million years ago. During the same period, the earliest herbivorous dinosaurs also appeared in the fossil record. One example is Pisanosaurus, a small dinosaur about 1 meter long and weighing between 2 and 9 kilograms. Its teeth were tightly packed, forming a continuous cutting edge used to chew and grind plant material. By the late Triassic, at least 15 different types of dinosaurs had already emerged. With the arrival of the Jurassic period, Earth's climate gradually shifted from hot and arid to a warmer, more humid subtropical regime. Cycads, ginkgos, and conifers expanded into vast forests, the air growing warm and moist, filled with tropical breezes. Early in this period, the breakup of Pangaea accelerated. The northern landmass, Laurasia, gradually split into North America and Eurasia, while the southern continent, Gondwana, began to fragment during the Middle Jurassic. Eastern Antarctica, Madagascar, India, and Australia slowly separated from Western Africa and South America. Newly formed oceans filled the gaps between the drifting continents, and massive underwater mountain ranges rose, pushing sea levels higher and allowing seawater to flood inland. These waters helped create the humid subtropical climate, turning barren deserts green as cycad-like plants and true-leaved trees such as conifers flourished. The oceans teemed with diverse life, with marine reptiles occupying the top of the food chain. Typical representatives included plesiosaurs with long necks and paddle-like limbs, along with giant marine crocodiles, sharks, rays, ichthyosaurs, and abundant shelled organisms such as ammonites, gastropods, and mollusks. Coral reefs expanded rapidly in warm waters, while microscopic plankton multiplied explosively, sometimes turning parts of the ocean red. By the late Jurassic, the earliest birds, such as Archaeopteryx, took to the skies for the first time, likely evolving from small theropod dinosaurs. Their flight, however, was far from peaceful, as they had to compete with pterosaurs, flying reptiles that had dominated the skies since the late Triassic. On land, insects such as leafhoppers and beetles increased dramatically, while the earliest mammals scurried under the feet of dinosaurs, struggling to survive. Meanwhile, dinosaurs began to leave their mark on the planet in earnest. Small quadrupedal herbivorous dinosaurs gradually evolved into giants weighing tens of tons. One such sauropodomorph, Mamenchosaurus, stood about 16 meters tall, reached lengths of up to 26 meters, and weighed around 25 tons. Another enormous herbivore, Argentinosaurus, grew to about 27 meters long and weighed between 30 and 50 tons. Their immense size may have offered some protection against attacks from large carnivorous dinosaurs. This era also featured fearsome predators such as Allosaurus, a massive carnivore measuring between 7 and 12 meters long and weighing about 2 tons. Each of its jaws carried 16 sharp teeth, which, like those of many Mesozoic predators, were continuously replaced. Individual teeth could reach lengths of 7 to 10 centimeters. Modeling studies suggest that Allosaurus was highly agile, capable of running at speeds of up to 34 kilometers per hour. Fossil evidence indicates that it preyed on Stegosaurus, though Stegosaurus was far from defenseless and could counterattack with its spiked tail, sometimes puncturing the attacker's bones. This formidable defense may explain why Stegosaurus survived for a relatively long time, even persisting into the late Cretaceous. As time passed, new predators emerged whose threat rivaled that of Allosaurus. Among them was Tyrannosaurus rex of North America, which could reach lengths of 12.5 meters and weigh around 10 tons, though some studies suggest its actual mass may have been only half of earlier estimates. Tyrannosaurus was not the sole ruler among carnivorous dinosaurs. Its power may have been matched or even exceeded by others. In South America, Giganotosaurus was similar in size and weighed about 9 tons, while Africa's Spinosaurus reached up to 10 tons. Even so, Tyrannosaurus remained a ferocious, and remarkably unhygienic, predator. Studies show that its tightly packed teeth often trapped rotting flesh and pathogenic bacteria. Such infected bite wounds could kill prey that initially escaped, though the process might take days or even weeks, sometimes allowing another Tyrannosaurus to benefit from the outcome. Analysis of its skull indicates a bite force ranging from 90,000 to 120,000 newtons, with a maximum of up to 200,000 newtons, enough for each bite to tear away approximately 225 kilograms of flesh. However, Tyrannosaurus rex, like Ichthyosaurus, also faced certain challenges when hunting prey. During the same period and in the same regions where Tyrannosaurus lived, there were also heavily armored herbivorous dinosaurs. The most iconic of these was Triceratops. Triceratops had 3 horns on its skull, 2 large horns above the eyes and a smaller one above the nose. Its body mass ranged from 6.5 to 13 tons, with the largest individuals reaching lengths of up to 9 meters and shoulder heights close to 3 meters. Its teeth were arranged in a highly specialized way, with each tooth vertically stacked in column-like structures of 3 to 5 teeth, forming 36 to 42 complete dental batteries. This meant Triceratops could have as many as 800 teeth, all of which were continuously replaced, ensuring they remained perpetually sharp. Combined with a narrow beak and powerful jaws, it could easily chew tough vegetation and even woody plants. Triceratops was one of the last groups of ceratopsian dinosaurs to evolve during the late Cretaceous. Another equally impressive dinosaur was Ankylosaurus. Not only was it the largest ankylosaurid dinosaur, it was also the last of its lineage, living from the late Cretaceous until the mass extinction of dinosaurs. Its body was covered in thick, bony armor plates, and behind its head extended 4 backward-pointing spikes. Most striking of all was the bony club at the end of its tail, a structure especially effective at repelling predators. This feature was vital for Ankylosaurus, considering its neighbors included formidable carnivores such as Tyrannosaurus rex. By the middle of the Cretaceous period, one branch of the ornithopod dinosaurs evolved into the well-known hadrosaurs, or duck-billed dinosaurs. These animals were large, distinctive in appearance, low-slung in posture, and equipped with broad, hardened beaks used for chewing and shredding plants. Research suggests that hadrosaurs typically lived in herds and were capable of both bipedal and quadrupedal locomotion. By the late Cretaceous, sauropod dinosaurs grew even larger. Although Diplodocus and Apatosaurus were already enormous, Argentinosaurus, which appeared in the late Cretaceous, may have been the largest land animal in Earth's history. This colossal dinosaur reached lengths of 30 to 40 meters and weighed between 50 and 100 tons. Argentinosaurus belonged to the titanosaurs, a dominant group of dinosaurs during the Cretaceous. Like earlier sauropods, they were herbivores. Approximately 20 million years before the extinction of dinosaurs, a novel type of dinosaur appeared, the Pachycephalosaurs. These dinosaurs had extremely distinctive skulls that looked exceptionally thick and solid, with bony protrusions covering the nose and base of the skull. Scientists believe these structures may have been used either to defend against attacks from the last large predators or to display dominance within their own species, essentially, prehistoric headgear with an attitude problem. Currently, more than 700 dinosaur species are known, and it is obviously impossible to cover them all in a video lasting only a few dozen minutes. It is worth noting that during the Cretaceous period, some dinosaurs lived in cold regions near the poles, areas that lay within today's polar circles. The climate there may have included snowfall and glaciers, and during the 3-month-long polar nights, temperatures could drop as low as -10 degrees Celsius. Despite these harsh conditions, these polar regions were still home to many dinosaurs. In 2014, scientists discovered fossils of a miniature Tyrannosaurus in one such region, including parts of the skull and both upper and lower jaws. This dinosaur was named Nanoxaurus, or polar bear lizard, and measured about 6 meters in length. Research indicates that many dinosaurs were covered in feathers to cope with severe climates, and Nanoxaurus was no exception. Today, the scientific community generally agrees that all tyrannosaur species may have possessed feathers to help them adapt to their environments. In addition to Nanoxaurus, polar regions were inhabited by other dinosaurs as well, including ceratopsians, hadrosaurs, and some small feathered predators such as trudontids, along with small herbivorous dinosaurs like Leelinosaura. However, the golden age of dinosaurs was destined to come to an end. Although their extinction is undeniably tragic, considering that dinosaurs survived on Earth for about 180 million years, they can safely be regarded as one of the most successful groups of vertebrates in the planet's history. In fact, some of their close relatives are still very much alive today. Modern birds are actually the descendants of feathered dinosaurs. Even more surprising, crocodiles and the chicken in your backyard are close relatives, sharing a common ancestor as the last surviving branches of ancient archosaurs. As for the extinction of the dinosaurs, most people are already familiar with the story, and it has been discussed in earlier videos. Those who are interested can explore it further.
If you enjoy what you just watched, don't forget to like the video, share it with your friends, and subscribe to the channel to stay updated. This channel is dedicated to exploring top-ranked creatures and the mysteries of our world, from ancient times to the modern era. Stay curious, and we'll see you in the next video.